Welcome to our journey into the fascinating world of string theory. Today we'll explore this groundbreaking concept in physics that aims to explain the fundamental nature of our universe. At its core, string theory proposes that the basic building blocks of the universe aren't particles, but tiny vibrating strings of energy. These strings can vibrate at different frequencies, and each vibration pattern corresponds to a different particle. One of the most intriguing aspects of string theory is the requirement of additional dimensions. Unlike our familiar three-dimensional space and one-dimensional time, string theory suggests there are up to 11 dimensions, some of which are hidden from our perception. String theory attempts to unify the four fundamental forces of nature: gravity, electromagnetism, and the strong and weak nuclear forces. This unification has been a major goal for physicists, aiming to bridge the gap between general relativity and quantum mechanics. There are several versions of string theory, including Type 1, Type 2, and heterotic. These theories differ in the types of strings they consider and how they interact. Eventually, they led to the development of M-theory, which suggests all string theories are part of a single framework. If proven correct, string theory could provide answers to some of the deepest questions about the universe's origins, the nature of black holes, and the behavior of particles at the smallest scales. It also offers the tantalizing possibility of parallel universes and alternate realities. String theory is incredibly complex and relies heavily on advanced mathematics, including higher dimensional geometry and topology. This complexity makes it both a powerful and challenging field of study. One of the biggest challenges for string theory is experimental verification. The scales at which strings exist are so small that current technology struggles to test the theory directly. However, ongoing research in particle physics and cosmology continues to provide indirect evidence. String theory has its critics. Some argue that it's too speculative and lacks empirical support. Others believe it represents a step forward in our understanding of the universe, even if it's not yet fully proven. Despite the challenges, many physicists are actively working on string theory. Research is progressing in areas such as quantum gravity and the holographic principle, which may eventually lead to breakthroughs. String theory has also captured the imagination of popular culture, appearing in movies, TV shows, and books. It symbolizes humanity's quest to understand the cosmos at the deepest level. While it's still a work in progress, the ideas it presents continue to inspire and challenge our understanding of reality. If you enjoyed this video, please like, share, and subscribe to our channel for more fascinating explorations into the wonders of physics and beyond.